So if you want to, there's still a few chairs free in the front. So I will be showing some code. So if you want to reevaluate your seating position, this would be the right moment to choose one of those 7 free chairs here. Or you have really, really great eyesight. That's also fine. Thank you. All right, so my name is Wietse Venema, and I'm an engineer at Google Cloud, based out of Amsterdam. And I once wrote an O'Reilly animal book, and I love explorative coding. So, because that's how I learn new things, right? So building something, actually building something, helps me build deeper of an understanding of the technology, and every single time I do this, I wish I did it more often. And my latest exploration, and that's the one I'm sharing with you today, is all about RAG and ReACT, not the web framework, and large language models. Have you heard about those? Yeah. Postgres, vector databases, and text embeddings. Ooh, another thing, it's a fairly small group, so if you at any point during this presentation have the feeling like, what is this guy talking about? I have a burning question I want to ask, just raise your hand, ask the question, because I'm fine with it, you won't break my flow, and it will be more interesting for everyone if you do that. So do ask questions. I'll watch the time and make sure that we don't go over. Okay, so do you recognize this website? Okay, so this is a website where nerds go to share links, and they will comment on it. So fairly interesting stuff happens there. So interesting links and strong opinions, sometimes even technical. But those common threads, they can be super insightful, right? So just the other day, there was this thread about how ESA, the European Space Agency, has an experiment to have satellites fly information, in a formation. And it's also an anonymous forum, which is usually very bad. But hey, this is actively, strongly moderated by Y Combinator. Yeah, so here's Hacker News, and there's a link. You can go to the link and a bunch of comments. So just in those comments, I'm going to do something with this session. Oh, and here's my app, because I built a little app that lets you ask questions to an LLM, but grounded in those comment threads, right? So if I ask this question, it will go over 20 million comments and find relevant comments and answer the questions. Just say, whoops, this is how that works. Can satellites fly in formation? I'll come back with a response, grounded in those Hacker News comments, which is awesome, right? So another question? This is where it gets dangerous. Audience feedback. No? Okay. What are alternatives to single-page apps? Okay, HTMX, Alpine. And this is funny, every time it's something else, right? So when I practiced it, gave this bullet list with all the nice alternatives, and this time it's something completely different. But hey, that's the randomness that we have to enjoy with generative AI. Okay. So the architecture of my app is user sends a query to my app, it will find relevant common threads, fill in those into a prompt template, and that prompt goes to the large language model, and then the answer is returned to the user, right? So that's what happened here. Answer is returned to the user. And this is this is called retrieval augmented generation, or RAG, which is a very fancy name for something very simple, because this is all what it is. This is the actual prompt that I'm going to be sending. You are an assistant for question answering tasks. Use the following pieces of context to answer the question. If you don't know the answer, say that you don't know. Remember hallucinations? They can be very creative, those generative AI models. So there's a question and some context. So that's the prompt template. I'm going to fill those in. can satellites fly information? Then I will take that same query, go to my data store, use that same query, and retrieve relevant comment threads. And I'll paste those into the same prompt. And this is what I sent to the LLM, and I got something back, which is, well, this time it's very similar to the answer I just got. And this is interesting. I already used my tool because I wanted to know, like, hey, what other alternatives are there to vector databases? Or what actually is the thing we should be using if you don't like single-page apps? And it made me discover HTMX, which is a super interesting library that you need to explore. At least I explored it and I liked it. But let's start here. Like, find relevant comment threads. And I'm completely going to ignore that Hacker News already has a search API, because that would make it way less fun, right? So I'm going to find a way to get all the data in Hacker News, store it somewhere, and find a way to search over them. And there is an API, right? There is, here they documented it on GitHub. I can choose the story that I just clicked on, copy the ID, and there you go. I got a nice JSON form thing back. So user, number of comments, the direct descendants, like this is all the IDs of a comment, title, URL that was linked to. And if I take one of those comments, select the same URL, get the same back, right? You can see a little comment tree appear here. Yes, so unfortunately, I couldn't find any data dumps of this Hacker News data. So crawling the API is what it is. And that's going to be simple, because it's just over 40 million items. Like, an item is a comment or a post, as you just saw, that exists today. And I'll request all those items individually, walking down from the last item, because all the IDs are auto-incrementing. So if I know the maximum item ID, then I can just walk back and request all of them, right? You like this approach? OK. I decided to dial down my ambitions a bit by just making it 20 million requests. OK, so that's 20. Item number 20 million is from May 24 in 2019, so that's long enough. So I'll have some good amount of data to look at. And I did some calculations. I'm really bad at math, but this is something I could work out. So if I send 1,500 requests per second, it will take me about 4 hours. And I'll store the items in Postgres. And I'll get back to why I chose that later. So how did it go? So the first decision I made, like, I work at Google Cloud, so I'm a bit limited in the options I can choose. So, but hey, I decided to run this job with Cloud Run. And Cloud Run is a product in Google Cloud that lets you run a container from start to finish with a timeout of up to 24 hours. So that's good. Put my code in the container image, push it to Cloud Run, execute it, and I'll get the results back. Because I'm sophisticated and I'm not running this on my laptop, right? I'm sure you can relate with that. So my first attempt is one for loop. Like, no reaction here. Like, this is an incredible dump. But I like to start simple, right? And then add more complexity later when I actually need it. So I tried this for loop, get the item, store it in the database. This is Go, by the way. I like Go. I also like Python. I like many languages. I'm very open to different languages. So this first attempt took forever. I didn't even let it finish. And I only got 3% CPU utilization on my instance. So I can do better. And so my second attempt was to use Go routines to increase my utilization. So I made a channel. I pushed all the item IDs to that channel. And then I started 200 Go routines. And each they would try to pull items off the channel and do the thing with it, right? Get the item by ID and insert it into the database. And then wait for all of them to complete. This was better. Definitely faster, about 200 times as fast. And it got me to increase the CPU utilization. But it was still not good enough. So what did I do? I went to Cloud Run jobs, and I turned on parallelism. So I could start not just one container, but 160 in parallel, and they would each do the thing. Oh, and I would assign like a chunk of the 20 million items to each individual container. This was better. CPU utilization was, oh yeah, one other thing. My third attempt failed because I had undersized my PostgreSQL instance, and the CPU was going to 100%, and that didn't make it faster. Okay. And finally, I succeeded. So if I select all the item counts, you can see it's a little over 20 million. Yeah, yeah, yeah. Thank you. Like like the rule is kind of that I shouldn't be asking for the applause. You like if you see my and you enjoy my success, you need to encourage me. Like okay. I should have said it at the beginning. Okay, so now I have all those items, but the thing I want to be indexing is comment threads, right? And the resource model is item, right? There's an ID, there is a type, which is story or comment. There is a parent ID, which is either another comment or the original story. There's all the direct descendants, right? The children of this item and the URL if it's a story. So my first attempt, like I want to have all those IDs and then turn them into a common thread. So I wrote fancy SQL because I really like writing SQL, and especially with those ChatGPT and Gemini, I can write really fancy SQL even faster. And I didn't know this existed, but this was a suggestion. Like I described my problem, and I got something that used with recursive, so I researched it, and this actually works. Like you can do a subquery, and it will recursively call itself, and then I got all the items of a story. And it was great. It worked. But then I tried to run it like for the 20 million items, and for some reason it became slow. So I decided not to waste time debugging the query. Maybe I had to add an index somewhere. I don't know. So I thought, okay, this is my moment. I spent so many hours practicing for my Google coding interviews. This is where I can do a pre-order traversal on a tree. And actually, it's useful. So that's what I did, right? So I created my stack, and I pushed like the parent story node on it, and then added it to the incrementally added it to the common thread. I keep track of the depth, so I can do like the fancy indentation. And then I add all the children in reverse order on the stack, because well, otherwise they will be reverse ordered in the output. And I keep doing that until the stack is empty, right? And then I've rendered the entire common thread. So great success. Thank you. We're best friends now. Okay, so but I still need to like figure out the whole search thing, right? So because I now have all those documents in. Yeah, question.
Yeah, a question about the recursive. How's the performance on those recursive queries?
The recursive queries, it was pretty okay, but when I ran it, maybe I tried this before I like changed the resource allocation on my Cloud SQL instance. So maybe it was just at like 100%. Well, I did this and then I changed. Like I'm not too scientific when I like have my weekend coding project, but hey, I'm pretty sure this would have worked too. But I also like my many little queries thing. Thanks for the question, by the way. Yeah, so I am going to use text embeddings. So I grew up in a time where if you wanted to build a search engine, you had like SQL-like statements, and that was pretty awesome. But now we have text embeddings. And text embeddings, for those who are uninitiated, are arrays of numbers that represent text. And their purpose is to capture the meaning and relationships between words and concepts. Now, if that sounds a bit abstract, they are useful because you can use them to calculate the similarity between texts, like find related items, or implement document search. So I'll take my query, I will calculate the embedding, and I'll calculate it's a vector, so I can calculate the distance of my query to all the documents I have, and I can get a list of documents that are very related to my query, which is exactly what I want. Okay, Cool, so how to create those text embeddings? So you can either use open source models or a proprietary API. And like I said, I work at Google Cloud, so I'm pretty limited in the options I can choose. So I will use the Google Cloud Vertex AI text embedding API. Well, that's a mouthful, but at least the name is very descriptive, right? It's an API, you get text embeddings. I like that. A few challenges I had to solve. So the first challenge is this API is rate limited at 1500 QPS. That's today, maybe tomorrow it's more, I don't know, but that's something I had to work with. But luckily, it also supports batching. So instead of sending one text and getting one embedding back, I can send up to 100 texts in one request and get 100 embeddings back. So that's, well, that gives you something to work with, right? A related challenge is that the token size per request was limited. So in reality, when I send all those common threads, I could batch like 3 to 5 common threads together to get the embeddings. So here's how I solved it. Go program, again, because it's really easy to do concurrency. How it worked, I have a bunch of Go routines that got the stories and rendered those common threads. Put those on a channel, and I had a bunch of Go routines that made the query embeddings. And those Go routines handled the batching and the rate limit. So it would try to pull items off the channel until the batch was full, or it figured out that the token size limit was reached, and then it would send the request. And then the results, it would put it on another channel to the next Go routine that would update the document. And this is an amazing pattern in Go I really like. So Go routines work, you can have many, yes, question.
I'm sorry, for the text that you use, that's just like basic text, nothing special, that's only all the comments within one comment thread.
Yes.
Just enter, separate or something.
Yeah, I did that, yeah. So I did, I removed the HTML, I didn't know why I did it, but it felt right. It made it look nicer. I added the indenting so that the structure of the conversation was visible. I don't know, maybe that was useful for the LLM. I don't know. It was I didn't really talk about it, but this very tiny text here, that was the result that actually went to the database, the whole thread. So it starts at the top, and then indenting makes it clear what. I'm not sure if that was even relevant, to be honest. Maybe it ignores white space, you don't know, right? But I could, if I was going to be really scientific, this is something I could have researched. Do I get better results? How do you judge the quality of the results? That's, I think, a pretty hard problem still. If you run this in production and you get LLMs generating responses to users, you want to know how good they are. How do you do this? Someone with an idea, or not? No. Mm-hmm.
Either open source or Google, but you generate vector embedding for that model, or?
Yes. So every model, I can't, if I use a different model to create embeddings I can't compare those vectors because they will map to a different spot, right? Yeah. So that's important thing.
So if maybe you do it for now and it comes out in a year, then you have to create all
yes, yeah. You have to use the vectors with the same model. So if a new version comes out, you need to redo all your vectors again. Yeah. Where was I? Yeah, and that's another thing of when I generate, you need to pay attention to cost with this. I spent I filtered a bit, so I only took stories that had a high enough score, and I filtered a bit, I didn't take too deep of the common threads to make the size of the things a bit smaller. I still paid 46 euros to convert everything, right? So that's maybe if I use an open source model, it maybe has lower quality, but it's still good enough for my use case. I only pay for my CPU, so maybe that's better. So it's definitely, you don't, not for every task, you need to take the most expensive model. Okay, so what's left is getting the search results. Oh no. Postgres, it has an extension that lets you do vector search, right? This whole thing of taking a vector and then finding all the like close by vectors. There's an extension for it. So I just have a new column in my table where I can store the vector. And then to search it, I'll do this query. Select star, all my document fields, and the distance between my query vector and my document vector as the distance, and then order by the distance. And then I get all the results. So all I have to do is wrap an API around it and deploy it as a Cloud Run service. So I'll show that. Yes, question?
So is the vector search the reason why you chose Postgres versus a native document database? Because to me, this was like, oh, I would store it in a document database.
Oh, sure. Well, I think everything would have been good. I have a slide later on why I picked Postgres. I'll show it. Why Postgres? Oh, excellent. Like I sort of felt this was coming. So why Postgres? Well, the real reason is bullet point 2, because I really love SQL, and LLM chatbots make me even faster query writer. But historically, all the new data features end up in traditional databases anyway, right? So if you're like at an enterprise and you're deciding on like, should we start running, I don't know, Mongo? And like this was a few years back when NoSQL was a thing. Like remember when in a relational database you couldn't query over JSON objects? Well, you can today. So I think it's like long-term, it's a good bet to choose Postgres. But hey, the real reason is that I really like writing SQL. And Hacker News comments, I used my own tool, they tell me that there are dedicated vector stores like Pinecone, Weaviate. There's a really awesome talk about Weaviate later today by JP. Go listen to it, it's awesome. And they have lower latency and can be much faster for large data sets. But my forward-looking statement is I think it will eventually converge and Postgres will do everything. But I might be wrong. Search API, because I wanted to show this. Because I have my vector search, and this is a public URL, don't go and do bad stuff. So I can do my query. What would a good query be? Vector database, maybe? And I get a response back. It's all pretty printed. So ID, and ask Hacker News story, and then here's the body with the entire comment thread, and here's the distance. Okay, some completely different topic. Like, you now risk me showing content that might not be appropriate for the YouTube stream. So I'll do something really boring, like this is really dangerous. I tried recommend me Wikipedia pages. I don't recommend running the query. So I will do, what is HTMX? And it's like, this looks fairly good, right? Are you using HTMX? And then a bunch of people are explaining what it is to people asking what it is. Like that's why my responses are actually relevant, because on Hacker News, people really like to explain a question. Yes?
How many resources or how many retrieval systems?
Well, this is just that one query that I showed, like the output of this thing. But I will be, later, I will do more queries. And yeah. All right, so by Postgres, we covered this. Back to the code, right? And instead of, because I showed you this is the LangSurf playground, which is something that wraps around LangChain. LangChain is a library in Python that makes it very easy to write applications like this, right? It will have there's a bunch of components that you need when writing an LLM-based app, like a large language model, vector store, a way to do function calling, or like a whole bunch of those patterns. They exist for all the different providers and open source models, and LangChain abstracts over that, so it gives you a great interface to build this kind of apps. So instead of opening my IDE, I'll go to my notebook, which is here, to show how I did this. So a bunch of dependencies here, so LangChain, the Google LLMs. So the first thing I need to do, well, let me just skip to the most important thing. So this is my whole demo app, right? It's a chain. And I think this needs a bit of explanation because this doesn't look like ordinary Python, right? What's this vertical bar here? What does this do? And I have a slide on it. So a LangChain chain is a sequence of calls that translate a query into a final answer. So the first part is taking the query and sending the query to my search API, and then returning the query in the comment threads. The next part is filling those into the prompt template, right? Query, this should sound familiar because I covered it earlier. So the comment thread and the query go into the prompt template, and the prompt goes to the large language model, and the large language model delivers a response, and I render it, right? See how I highlighted the line so you can follow along? I'm really proud on this. Thank you. It makes it so much more fun when there's like interaction with the audience. Okay, so back to my. So there's the same code, and this is like, remember how I explained this retriever thing? That's a Python class that I implemented. So based on the query, I make a request to my search API, and I get a bunch of documents back, and I paste them into the thing, and I can use it on its own, right? So. Can satellites fly in formation? So there's a bunch of posts that come back, which is the whole purpose of the retriever. I paste them in the prompt template, and there's my chain. Okay, so this works good. And I like LangChain. It makes it really easy to prototype things, because this is a really, really simple, limited example of RAG. You can do way more complicated things. There is an amazing YouTube series called RAG from Scratch, and you should watch it because Lance from LangChain explains like all the relevant concepts in building like more advanced RAG, and it will handle challenges like how do you do evaluation, how do you do better queries? How do you figure out what queries go to what data store? Because vector search might be really great for my example, but it's not great if you want to have a query like, okay, for all the posts after 2024 or 2023, answer this question. So then you want to have a filter of some kind, right? So then, RAG from Scratch. It's really something you should see. Well, first hit in Google. Short videos also. I like short videos. Question?
Is it going to be built into Google search?
RAG.
Well, this, I mean, basically, you do search, it tells search is based on the, does it already do maybe?
Can I summarize the question as, do you want to share insights on the product roadmap of Google search? I'm pretty sure I'm not allowed. But thanks for the question anyway. Like, okay, cool. Try again later. Yeah, ask it a different way. Yeah, maybe try about please, or I'll give you a tip of $10 if you come with the right response. Like, yeah. Okay. So what about this ReACT thing I kept talking about earlier, which is not the web framework? It is a way to prompt LLM in a loop. Right. So there's this paper that was written by Google and Princeton. That demonstrates this pattern. I also implemented, there is a notebook where I worked out, I don't think I will have enough time to show that, but hey, here's how it works. So first prompt, you have this large ReACT preamble with a bunch of instructions that teach the LLM how to reason and act. You see how ReACT, like reason and act? I'm not going to show the instructions because it will become apparent from the example. So this is my first prompt. I have a question, and I say, like, for databases, I like to use proven technology. What database should I use to store all Hacker News comment threads and make them searchable? And then because I taught it to first reason and act, and I gave it a list of tools, right? It will start thinking. So this is the LLM, right? The highlighted part. I hope it's visible, like I highlighted the green part. This is why I asked people to move up front. I should ask what database Hacker News uses, and that would be a good database to use for this task. Well, it's a fairly reasonable response. And it also selects a tool to use. So it will say, action, search Hacker News. Action input is, what database does Hacker News use? Observation. Okay, so and this is where I get the response back. It will stop after observation. Right? So first prompt is done. I give it the ReACT preamble and the question, and I get the thought and the action back. So I will parse the action, and I will add the result of the action to the prompt. Still following? Yeah? Okay, so I add the relevant comment threads, like the context. I add it as an observation to the prompt. And then I will send this entire thing as a new prompt to the LLM. So now, like I'm actually calling the tool, but the LLM now thinks it can do something, right? It can call tools. So now I sent this entire thing as a second prompt, right? The preamble, the question, the first thoughts, the action it selected, and the response to that action. And then we'll continue thinking, right? Okay, so based on the comments I read, Hacker News uses Algolia for its search, but it doesn't say what databases it uses for the primary data store. Someone suggested MySQL, and that's also a reasonable choice. So the action it comes up with this time is search Hacker News for what database is best for storing lots of text data. Again, very reasonable. And it stops at observation, because I told that was going to be the stop sequence. So now, I'll parse again this whole action thing. I will add the observation. And after 3 prompts and 3 searches, it says Postgres is a good choice for storing and searching Hacker News comment threads. I completely cherry-picked this example. Because the other time I will do just one query and say, hey, based on the comment threads, I recommend doing Pinecone of Weaviate or one of the traditional databases. Redis has it too, right? So was this better for my use case? Not really. That's funny, right? It's like a better way to do prompting, but it didn't really work. Like based on my non-scientific evaluation, it really it didn't improve the responses much. But I can totally see if you have multiple tools and complex multi-step questions, I can see how this can be better. Because it came up with its own search queries. Maybe if I tell it to search data on my local disk or combine different data sources, it would be way more interesting. So I think this is very promising. There's also more variance in the responses, and I had a few more cases where it started coming up with something it made up. Yes, question.
Consider also using other prompting techniques like chain of thought, least to most, or something of that sort instead of ReACT?
The question is, did I consider also using chain of thought? Or
least to most, or other type of prompting way to interact with the LLM?
Sure. Yeah, well, ReACT is some kind of a superset of chain of thought prompting because I ask it to reason about its actions. So that's I think it's more of a superset. But yeah, there's definitely way more to explore. And if my weekend had lasted longer, I would have totally used more things. But also, 35 minutes is 45 minutes, right? Question.
Did you put down the temperature really low? Because then it's going to get more stable.
Oh, sure, yeah.
Giving back
This is another question. Is there's a setting, if you make a call to the LLM, there's a temperature thing, and the higher you put it, it will be way more variance in the responses. And if you put it lower, it will be way more predictable. I could have totally used that, yeah. It makes it kind of ooh, I have this magic button here, and I can... It makes me a bit scary, but maybe that's just me having to get used to the non-deterministic nature of this technology. And it needs more than one prompt to come up with a response, right? So that's compared to RAG, it's another thing. So I think with more guardrails, because it's just calling the LLM in a loop, and sometimes it would go on a completely weird thread and not come up with a reasonable response. And I think you might get, I looked into flow engineering, where they say, well, okay, we're not calling the LLM in a loop, but we're adding a bit more guardrails, and we built this whole flow, like a graph of actions that I can take and different nodes. Might work better for the next talk, I think. So that's everything I have. I have time for questions. I have a blog. You can. There's time for more questions, discussion. Like, if you, yeah, another question.
Yeah, it's a bit of an extension of this question. You also mentioned like you can use a proprietary vector store.
Yeah.
How would that have hooked up to this? If you did, because you just said that you can you make the vectors for the model. So in this case,
yeah.
the model in vertex.
Yeah. Okay. So the question is, why could I have also used a different vector store?
So
So
how is that compatible when you just said it has to be?
yeah. So a vector is an array of numbers. And in a vector database, you can store it and then query it, like give me, do a similarity search, right? Yeah. That's one thing you can do, or group all the similar vectors together. Like those operations don't depend on a model, like a vector is always a vector. But there will be this agnostic for the thing it does is store vectors. How you come up with the vectors doesn't matter. But if you want to combine factors of different that were created by different models, you're going to have a bad time. Like that was the whole point I wanted to make about that. So. Okay,
so the model makes the vectors.
Yes, model makes vectors. You can compare the vectors made by a model. You will likely have a bad time if you start to compare factors from different models. Maybe not, but that's the whole.
Okay. And different vector store would be faster or slower or whatever.
Trade-offs, engineering trade-offs. Yeah. Yeah, another question.
The solution you created using your PostgreSQL with vector search, that's meant to make sure your like if you use LLM, you are limited in the size of your context, right, for your prompt.
Yes.
So this helps you to limit, like an alternative could have been just to put everything in there, but
Sure. And Gemini 1.5 Pro now has 2 million token context. This is the marketeer, like, but yes.
Yeah, but like for you, this was a solution to limit your, like, is that that's my understanding? Am I correct in that? It helps you limit your context? So that's
yes. So like the whole thing, there is a trade-off, performance trade-off here. If you do like a 2 million items context, it will take a long time to get a response, and it will be more expensive because you pay per token, right? So that's also a way for ReACT to like optimize for cost.
yeah, exactly. And then if you look at ReACT is a totally different solution which also helps you limit your context sort of by
How?
splitting your questions and limiting your context, or
How I use, because RAG is a bit like, it feels like like you take the exact query that the user types and then find similar documents to it, and then you hope that they are relevant. They might not be,
yeah,
right?
exactly.
And then ReACT, how I used it, because you can also use like different tools than like search. I only provided it with search. But how I used it, it was hopeful that it would be able to come up with better search queries, or come up with a few search queries in a row that helped it build understanding and then come up with more relevant context. That was the idea. It didn't work for me. Another question.
Could you use ReACT to do a live API request on the Hacker News site? So don't do it in advance, but do it live after the first prompt.
To get an individual item, or
So first you
for
get a prompt from the user, then you can use ReACT on selection, and
Yeah.
then you get the second prompt.
yeah.
So instead of doing all the factorization in advance, you can do it live.
Yes, but how would I do a search? So then you would need all the items indexed, right? Yeah, but like the sky is the limit. Like a tool is just like a description of a thing that the LLM can like pretend to make a call to, right? It can be like book a flight to Honolulu, if that's like, yeah, another question in the back.
What metric did you use for your similarity in your retriever?
Cosine.
Cosine?
Cosine distance, yeah.
And a follow-up, how was the quality of the retrieval? Because I have issues with that. Like, was it actually relevant to your query?
Yes, it was. Yeah, I should.
Broad, but did it give like an actually specific chunk of text every time? How often did that happen?
I think it was good enough for my queries, because like if I asked something about vectors database, it came up with a post about vector database, so that was good enough. Another thing I could have done is like index all the individual comments, compute an embedding over those, and then retrieve comments, and then maybe even figure out like, okay, so I got 5 comments that were relevant to my search query from this story. Let's add that thread to the context. Watch the ReACT from Scratch series by Lance from LangChain. It goes over all those different. If there's nothing more, feel free to come up to me after the talk, and thank you for your attention.